Hi, and welcome to Chapter 14. So what we're going to look at in this chapter is firms in perfectly competitive markets. We're going to take these ideas about supply and demand we learned from Chapter 4, and we're going to combine it with the ideas that we learned about cost functions in Chapter 13, last chapter, and look at what firms do if they're in a perfectly competitive market. So here's why you should care. Let's imagine a scenario that you run your own business and you have to decide about production decisions. You have to decide price and quantity, how many workers to hire to produce that quantity, etc. So what factors affect these decisions? Well, first of all, your costs, like we studied in the last chapter, how much competition you face, and it really depends upon what kind of marketplace that you're in. We're going to start with this chapter by studying perfectly competitive markets. We'll study in subsequent chapters other types of markets. So you should be thinking, what is a perfectly competitive market again? Well, we talked about it in Chapter 4. Has many buyers and sellers. The goods offered for sale are largely the same. Firms can freely enter or exit the market. These are the hallmarks of the traditional perfectly competitive marketplace. You don't get to choose what marketplace each good is sold in. It's the type of good, it determines the type of marketplace. So a lot of people use the example of ears of corn to talk about perfect competition because a corn is a corn. It's all the same, like number 2. There's many buyers and sellers, like number 1. And anyone can jump in and start selling corn, or they can stop selling corn. That's part 3, okay? And the interesting thing about this type of market is that everybody's a price taker, meaning they don't get to set the price. Another way to say that is no market power. All right, so let's look about what the revenue of a competitive firm is. So revenue, total revenue, is just equal to price times the quantity, P times Q. P is the price at which you're selling, and Q is how much that you sell. Average revenue then is just very simple. We just divide it by however many output we sell, however much Q that we have, and we get back to P. This is kind of interesting. So on average, how much do I make for each thing that I sell? I just make P dollars. Well, this makes a whole lot of sense. And what's the marginal revenue now? Okay, so marginal revenue, remember that one of our principles is that we always have to think on the margin. So we're going to ask, what's the change in total revenue as I change my quantity? See, this is different than average revenue because this is the total average revenue divided by the total quantity. Here we're looking at what's the change in a total revenue versus a change in quantity. So the way to think about it is, if I take one more step forward and I produce one more Q, how much does my revenue change? Let's investigate that right now. Okay, so I want you to use the formulas that I showed you for the last slide to go ahead and calculate this chart. You can pause it and do it and on your slide, and then I'll give you the answers. Okay, so here, remember, here's the formulas that I gave you before. Total revenue. Boom, it's just P times Q. If I sell one, I sell it for $10 and I get $10 total revenue. If I sell 4, I sell each of them for $4 and I get $40 total revenue. Okay, now average revenue. I just divide by Q all the way through, or I can just remember that average revenue is always equal to the price. On average, each thing is netting me $10 in revenue. And marginal revenue also. The way to calculate this is it's how much, as I go from this row to this row, how much does my total revenue change? Well, it changes from 0 to 10. So my marginal revenue is 10. Here, it changes from 10 to 20, and my marginal revenue is also 10. 20 to 30, my marginal revenue is also 10. Remember that the marginal revenues are put right on the halfway points because it's the signal is it's as you go from 0 to 1 and 1 to 2. That's the way we think of marginal revenue. Okay, notice, this is really important, that marginal revenue always equals P in this chart. Okay? And this actually is true for every firm in a competitive marketplace. Okay? This is not true if it's, for example, a monopoly or something like that. But in a competitive marketplace, a marketplace that has the characteristics we discussed earlier, marginal revenue is always equal to price. Okay? And this is pretty interesting. That means a competitive firm can increase output as much as it wants without affecting the market price. So every time that you make one more Q, they go ahead and sell the Q. How much do they sell it for? They sell it for P dollars. This is telling us that marginal revenue is equal to P. This always holds, but only in competitive markets. Now, we've talked about revenue so far, but that's not really what we care about in a firm. What we want to do is maximize profits. We don't want to maximize revenues, because revenues is just the total amount of dollars we get. Profit now is revenues minus our costs. Okay, so now we're going to have to start thinking a little bit about costs. The question, what Q maximizes the firm's profit? Remember, we don't want to maximize revenues, we want to maximize profit. There's a difference. So we're going to think a bit at the margin, and remember, we're going to introduce the idea of a cost. All right. So if you increase Q by 1 unit, okay, I get MR dollars more, but it also costs me MC dollars, whatever my marginal cost is. Okay. So this is real simple. If my marginal revenue, this is how much I get from making one more unit. This is how much it costs me to make that one more unit. If marginal revenue is higher than the marginal cost, then go ahead and let's go ahead and increase Q. All right, Q goes up because that's going to give us more profit. And the same thing, if marginal revenue is less than marginal cost, meaning I get less dollars than it costs me to make it, then reduce quantity. Okay, and that will raise my profits. So let's go ahead and throw this chart back up that you did a couple slides ago. And I'm going to go ahead and add some costs. So this is my total cost. As you can see, if I have 0 units of quantity, it still costs me $5 because that's a fixed cost. Maybe this is rent for my building. And then there's $4 extra is the total, $4 more total cost if I produce 1. Then from 9 to 15, I think that's $6 extra, something like that. From 15 to 23, I think that's $8 extra. Okay, that's how the total cost function is working. So my marginal cost now is just the numbers that I was just telling you, the change as I go from 0 to 1, and 1 to 2, and 2 to 3 of my total cost. So don't forget, this is pretty easy. My marginal revenue is just how my revenue increases each time I take a step forward. And my marginal cost is just how my cost function goes as each time I take a step forward, okay? And this is my total cost and my total revenue that I'm using to calculate these columns. All right, so profit, very simple. This is the very thing that we want to maximize, and you just take total revenue and you minus total cost, and you get the profit. Okay, so at any point I can easily calculate 30 minus 27, 30 minus 23, excuse me, gives me 7 profits. So if I want to maximize profits, I'm looking like somewhere around here is the maximum number of profit. Okay. So if I calculate my change in marginal profit, that's my marginal revenue minus marginal cost, I see something here. Right here, at this point, marginal revenues equal marginal cost, okay? At any Q where marginal revenue is above marginal cost, okay, so that is 1, 2, 3, these places here, when marginal revenue is greater than marginal cost, really what I want to do is increase Q. If my marginal revenue is greater than my marginal cost, I want to reduce Q. When my marginal revenue is equal to my marginal cost, that is where I want to produce. So between 3 and 4 units is going to maximize profits for this perfectly competitive firm. All right, so the marginal cost function is often upward sloping, like we saw, and the marginal revenue function is flat, like we saw from the last table. And the reason why this is always flat is because this is the price that I'm getting for the good, and this is how much I'm paying for each individual good. These are not total cost and total revenue functions. These are just marginal cost and marginal revenue functions. That means as I go from low levels of Q to high levels of Q, that my marginal cost is increasing. So when I'm at low levels of Q, my marginal cost is low. It's underneath marginal revenue. So I obviously want to produce more. But if I'm producing too high, marginal cost is above my marginal revenue, and I want to decrease right until this point, marginal cost equals marginal revenue. Okay, this is the exact same thing that I showed you from the table last slide. It's just a different way in case this helps you understand it better. All right, so if I change my Q from Q1, that my profit is going to be lowered. All right, so this is really simple. Marginal revenue equals marginal cost at the profit maximizing quantity. This you can memorize for the rest of your economics career. This is always true, okay? Marginal revenue is always equal to marginal cost. This is always true no matter what kind of the marketplace. If you set marginal revenue equals marginal cost, it will give you the Q that maximizes your profits, okay? Remember that for perfectly competitive, we had this slightly modified one was price equals marginal cost. But for all firms, no matter what type of market structure, marginal revenue is equal to marginal cost. Okay, so let's imagine a price rises to P2. This is simple. How much should I produce at? Well, I just go to where the two curves cross, right? So if price increases, then I should go ahead and produce more, and this makes sense because I'm going to be able to get more revenues. So if you look at this, this is kind of interesting. The marginal cost curve will actually tell you exactly how much this firm will produce, because it's always going to produce exactly on this curve as price raises. So it really turns into a supply curve. Okay? It turns into the supply curve for the individual firm. Okay. Now, what happens if we can't produce anything because market conditions, i.e. the price, is too low? All right? And there's two ways to think about it. There's a short run shutdown, just turning off my factory for right now. Then there's exit, meaning selling everything that I have, selling my factory, and leaving. All right? So in the short run, if you shut down, if you turn off your factory, you still have to pay whatever fixed costs that you have, perhaps rent on the factory. But then if you wait until the long run, then you can sell everything and then you'll have zero costs. All right? So we have to remember about this fixed cost in the short run. And what's the length of the short run versus the long run? Well, the short run turns into the long run, however long it takes to sell everything in the in your factory. So perhaps you have a 1-year lease on your factory. That means the division between short run and long run is 1 year. Okay, so there's a cost of shutting down. I lose money, but I also don't have to pay my variable costs, right? I still have to pay my fixed costs, but I don't have to pay my variable costs, which is like the labor or the cost of materials. Okay, so if total revenues are less than my variable costs, go ahead and shut down. This makes sense. And on a per unit scale, this means divide both sides by Q. Total revenue divided by cost, total revenue divided by quantity is just price. Variable cost divided by quantity is just average variable cost. So if the price is less than the average variable cost, I should shut down, turn off my factory right now, even if I have to pay fixed costs, because this means that the price I'm getting for my good is less than whatever the cost of the raw materials are, right? It's just I'm losing money by keeping producing, so I should just turn my factory off. In the short run, then, we have a firm that produces along the marginal cost curve. Remember, we said that the marginal cost curve is the firm's supply curve, but it's only above the AVC, right? It's only above the AVC, because if I'm down here in this direction, I'm better off not producing at all, okay? And so then it goes ahead and produces zero quantity if it's below AVC. So the portion above the AVC of the marginal cost curve is, in fact, the firm's supply curve. Now, let's take a quick second to remember about these sunk costs, or you can think of them as fixed costs. It's a cost that has already been spent. You cannot get it back. So it's irrelevant, because I'm always thinking about on the margin. What does one more or one fewer quantity get me as far in terms of profits? If I have to pay sunk costs, I have to pay it whether I produce more or produce less or shut down. So it doesn't really matter. Okay? Fixed cost is this sunk cost. It must pay it whether it produces or shuts down. So the fixed cost actually doesn't matter. In the long run, though, we think of all costs as variable. There are no such thing as fixed costs in the future because I can just sell everything given enough time. So if I'm going to exit, I lose the revenue, but the good thing is I don't have to pay any of my costs. So if my total revenues are less than my total costs, this is kind of a no-duh condition, right? I need to get out of here. If total revenue is less than total costs, I can't sustain. It's not a sustainable situation for me to be in. So on a per unit scale, right, I just go ahead and divide both sides. TR divided by Q will give me P. TC divided by Q will give me average total cost. So if my price is less than my average total costs, then I'm going to exit. And this is kind of just like the general profit condition. If the price P that I can sell it for is less than the average that it costs me to make it, then I should probably exit in the long run. Maybe go back to school or something and get a job at a regular firm. Okay, so on the flip side, should you as a new firm enter? Well, I want to only enter if total revenue is greater than total cost, and divide both sides by Q, and if price is greater than average total cost, then I go ahead and and then I enter. So on a per unit scale, this is basically the profit from, each unit I sell, because this is the revenue and this is the cost of each unit, and then the difference between these is the profit. So the firm's long-run supply curve is the portion of the marginal cost curve above the long-run average total cost. Okay? Remember, when we're talking about the short run, there's also this guy in here that's called the average variable cost curve, and I'm able to produce as long as I'm above the average variable cost curve. That's only in the short run, okay? So let's delete that. In the long run, what I care about is long-run average total cost, not average variable cost. And the supply curve is only the part that's above the total cost curve. All right, so here's what I want you to do. Here's a firm, and this is the per unit scale, right? That we have marginal cost, marginal revenue, and average total cost. I want you both to tell me the number that is profit in this firm, and I want you to shade in the area on this graph that indicates the profits. Okay, so you see this is the profit per unit, right? 10 to 6. I get to sell it for 10, and I get to keep it for, I get to pay $6 to make it. And I knew that I was going to maximize at 50 because this is where my marginal revenue and marginal cost curves intersected, so I knew I was making 50. Well, at this point, I know I can sell for 10 because I always sell for 10. And this point, the average total cost curve just tells me how much it's costing me, which is $6. So, okay, so I have $4 of profit per unit, and then I'm making 50 units, so that's 200. And then I shaded this area right here on the graph. Okay, same thing. Let's go ahead and determine this firm's loss because price is under the average total cost curve. And we're going to pretend that the average variable cost curve is down here somewhere because remember, the firm would shut down if the price were under the ABC curve. So we're going to pretend the ABC curve is under here somewhere so that they produce, but they're still wasting money. Or excuse me, they're losing money. But they're not losing quite as much as they would if they had to shut down and pay a fixed cost. All right, so here we go. There's the loss per unit is $2, and in the same way, there's 30 units that are being sold, and so the total amount that they lose is $60. Okay, let's talk about some of these assumptions for market supply. So all the existing firms and the people who could potentially enter have identical costs. Each firm's costs do not change as other firms enter or exit the market. The number of the firms in the market is fixed in the short run and variable in the long run, okay? This is because in the short run, let's imagine that it's a factory, and so it takes time to build a factory. Maybe it takes a year to either buy or sell a factory. That means that the short run is 1 year long. Nobody can enter in for the next 1 year because it takes a year to build a factory. But in the long run, after 1 year, we can see people leaving and coming into the marketplace. All right, so the short run market supply curve, right? We know that as long as price is above ABC, that each firm in the short run will produce right along the marginal cost curve, okay? And again, the total market quantity, right, is just the addition of all of the quantities made by all the firms. So we know each individual firm will produce on its MC curve. How much does the whole market produce? Well, it's just you add up however much all the individual firms are making, okay? So we have the graph for one firm here, and each firm is just one of 1,000 identical firms, okay? So if the price is right here at P1, then we just say, hey, well, one firm's making 10 of them, so the whole market is going to have 1,000 firms making this, or 10,000. If the price increases, right, we know that the one individual firm is going to produce on his MC curve, right, okay, because that's the supply curve. That means in the marketplace we're going to have 20,000. And then again, if the price raises again, we know that the firm will maximize at his, where his price and marginal cost curve crosses, which is 30, and then that will give us 30,000 total in the market. Okay, so when I draw that, you see it's just a horizontal summation of everybody's individual supply curves. We just add them up side by side, and we get the market supply curve. All right, so in the long run, the number of firms can change due to entry and exit. So what I just showed you was the short run idea. In the long run, though, people can enter. So if existing firms are earning positive profits, guess what? New firms are going to enter. and the market supply curve shifts to the right, okay? Which makes the price fall, reducing profits. And then if the existing firms are incurring losses, this is the flip side of the coin. People are going to drop out of the business, right? And the market supply curve shifts left, bringing the price back up. Okay, so basically, in the long run, everybody only earns zero economic profit. This makes sense. If firms were making profit, other firms would jump in until no one was making any profit. This means price is equaling to average total cost. We know that firms produce where price equals marginal cost. So the zero profit condition just means that price equals average total cost. And the marginal cost intersects the average total cost curve at the bottom of the average total cost curve. So in the long run, the price hits the bottom of the average total cost curve. Now, hopefully you're asking this question, wait a sec, zero profits? How are firms staying in business? This is zero economic profit, okay? Firms earn enough revenue to cover the costs. Accounting profit is actually positive. So they're actually making money if we're not talking about opportunity costs, okay? Accounting profit is positive, but they're only making as much as their opportunity cost is. So here's what it looks like in the long run. Okay, the typical firm earns zero profit. So I know that price has got to be at the bottom of my long run average total cost curve, and the marginal cost curve already, I know that the marginal cost curve always crosses the long run average total cost curve, right, at the minimum of the long run average total cost curve. Okay, so I know it always crosses there. And then I know that in the long run, eventually the price could start out up here, the price could start down here, but in the long run, it's going to go to this place, which is at the bottom. Okay, so let's go ahead and see what that looks like over in the marketplace. Well, I know that price is always going to end up being whatever this minimum ATC is. So the long run supply is flat, meaning no matter how much is produced, how much Q is produced, it always is produced at this price right here, right here. That is the price that we got from the bottom of the average total cost curve. Okay, so let's imagine that a firm is in long-run equilibrium. How do I know it's in long-run equilibrium? Well, because price is at the bottom of ATC. Okay, we have a long-run supply, and my short-run supply and my demand curve are all crossing right here at this point. So that's how I know that I am in long-run equilibrium. But then let's imagine that there's an increase in demand, okay? So you see that the demand curve goes up, and I'm going to draw this in the market because the demand for all of whatever this product is, perhaps it's ear of corn, more people want to eat ears of corn. So what's this going to do? Well, I know that this pushes the price up because, let's go back, remember simple supply and demand. When the demand curve shifted up like this, then the equilibrium point, instead of being here, was right there. So now the market price is P2. And remember, let's go back over here. I just take this price over to my firm. Each firm just has to, whatever the market price is, P2, each firm sees that as their price, and it's flat. They can sell as many as they want. Well then, what's this one firm going to do? Well, now he's going to produce here instead of producing here. So let's look at that. Okay. And then there's profits when he produces at that point. But what does this mean? If there's profits, more firms will come, which means the supply curve is going to shift back down, which is going to do what? Bring prices back down, okay? And so the prices come down. So the price comes back from P2 to P1, and it drives profits down to 0. Now this is very interesting because you see that in the long run, first we had Q1, but then there was this increase in demand and increase in supply that took us to Q2, that took us to Q3. So overall, in the marketplace, there's much more being produced, but each firm is once again producing at this point. Now, how can that be? Each firm is producing as much as they did under Q1, but there's way more total amount in the market. The answer to that is these additional firms, right? All the firms are still producing at their minimum ATC, but now there's a whole bunch more firms. That's why the market now sells Q3 versus Q1. All right, now I did just tell you the long-run supply curve is flat, but it might, and it's generally horizontal, if all firms have the identical costs and costs do not change. However, if any of these are not, either of these are not true, the long-run supply curve might slope upwards. So let's think of why would that happen. If firms have different costs, then the more efficient or lower cost firms enter the market, and then as P keeps increasing, then more firms will enter, these maybe perhaps older, less efficient firms, and so the long-run market supply curve slopes upward. So at any P, for the marginal firm, price equals a minimum ATC and the profit is equal to 0. So this idea that price is equal to the minimum ATC is still true. It's just each firm has a slightly higher average total cost curve. So it looks something like this, right? This firm has an average total cost curve here, and then the next firm, perhaps his average total cost curve is up a little higher, and then the next firm, his average total cost curve is up a little higher. So if we were to put these on a graph, right, you can see that the long-run supply would be, in fact, sloping upwards. Okay, and then these lower cost firms are actually going to make positive profit. All right, so costs rise as firms enter the market. Let's imagine that, because perhaps, I don't know, the supply of land for farming is fixed, and as you get more and more firms entering the market, it's actually making it more expensive because land is running out, right? That's how real estate works. So the price of land is rising, and this makes all the firms have higher costs. And so as P has to be increased in order to get Q increased, because, you know, if you want to have more ears of corn, more farmers need to buy farmland. Farmland's then going to get more expensive, so we need to actually pay more for the corn as Q increases, so it's upward sloping. Okay, so in conclusion, some really cool things about a competitive market. We know that always it's true marginal revenue equals marginal cost, and in perfect competition, we know that price is always equal to marginal revenue, so therefore, price is equal to marginal cost. But this profit maximizing condition is only true in a perfectly competitive marketplace, okay? And this one too, actually. And marginal cost is the cost of making the very next unit of Q. P is how much revenue you get from that Q. So basically, when I'm equating price equals a marginal cost, it maximizes total surplus, meaning it's efficient, meaning consumer and producer surplus is maximized because we're only producing as much as people actually want. How do we know? We're producing until the price, which is what people are willing to pay, is equal to how much it costs to make the good. Okay? So then we'll talk about monopoly next, which totally throws a monkey wrench into all of these ideas.